Okay, so the last one we're going to do, we're going to be doing the K. And it's essentially going to be the same thing as the A, except it's going to be for horizontal. And there's also going to be a difference. So we should probably do this one on the grid as well. So again, we'll say f of x is root x. And we do that over here. So that's our f of x. Now, what might it look like? So it will look something like this. So it's going to be inside the function. So it's going to be the root 2x. So that makes it to a k. If it was on the outside, it's an a. If it's inside, it's a k. Now, when we had the 2 before, it was actually a stretch. But for the horizontal stuff, it's going to be a horizontal stretch or compression. In this case, it's actually going to be a horizontal compression. So it's going to squish it this way. So it's going to look something like this. So that's our g of x. It's been squished this way over there. And similarly, if we have, for example, the square root of x over 2 or 0.5x, which is the same thing, that's going to be a horizontal stretch. So we're going to take that point, we're going to stretch it out this way. We're going to stretch it out, not drawn too well, but it's going to be stretched out in this way. So g of x is a horizontal compression, h of x is a horizontal stretch. Similarly, let's write this down again. F of x is a f k x minus c plus d. So f of x equals root x. And then what we're going to do with it, we're going to have a root of negative x. And what a root of negative x does, possibly predictably, so the negative is, again, a reflection, but this time it's going to be a reflection over the y-axis. It's going to reflect over this way. So sorry, that should be I want that to be a g of x. I don't know why I keep on writing f of x for that. So that was our original, so that's our f of x over there. And then the g of x with the minus is going to look something like this. And that's our g of x. And just like the a, we could combine those things. So we could say, for example, h of x equals the square root of minus 3x. So that's going to be a horizontal reflection and a horizontal compression. So it's going to reflect and squish a little. So that would be h of x. Note it still goes to infinity, it just goes in a more compressed manner. So for the k, it's slightly different. For the k, we're going to have our number line. We're going to have the number line, then what we see is actually, if it's bigger than 1 or less than negative 1, it's now a horizontal compression. So this over here is a horizontal compression. And if it's there or there, this is going to be a horizontal stretch or a horizontal stretch. And again, if it's 1, if k is 1, then there's no stretch or compression, and if k is 0, things have gone terribly awry. Now, one little wrinkle with k, you will notice that in the formula when it's written out, it's kind of been it's kind of been factored out. So it's been factored out of that. It has to be in that format. So for example, if I had an equation, g of x equals the square root of 2x plus 10, what I need to do is I need to rewrite it as, I don't actually know what the c is. I need to rewrite it in that format, so I have to common factor out the 2, and that would be what it actually is. So this is a left 5 and horizontal compression of 2. Similarly, if I had, imagine I had something like this, the square root of 10 minus 2x, that's not really in that format at all. So I'm going to rewrite it as minus 2x plus 10. Factor out the negative 2, it becomes minus 2, and that's going to be x. 10 divided by negative 2 is minus 5. So that'd be right 5, horizontal reflection over the y-axis, and compression by